life did not begin as cells. The earliest living systems were fragile, loose collections of molecules, barely separated from the world around them. They could replicate, they could evolve, but they could also fall apart just as easily. If life was going to persist, it needed a boundary, something to hold chemistry together. This is the story of how life became cellular. The problem of early life. On early Earth, chemistry was everywhere, but stability was rare. Water diluted reactions. Heat disrupted fragile molecules. Energy was unpredictable. Early life existed in a constant struggle between organization and collapse. To survive, it needed a way to separate itself from the chaos of the environment, while still exchanging matter and energy with it. That solution came in the form of membranes. The power of a boundary. Certain molecules, lipids, have a remarkable property. When placed in water, they naturally arrange themselves into spherical shells. No instructions, no machinery, just physics. These shells form compartments with an inside and an outside. For early life, this was revolutionary. Inside a membrane, chemical reactions could occur more reliably. Molecules could accumulate instead of drifting away. Replicating systems gained protection, persistence, and continuity. A boundary turned chemistry into a system. From protocells to cells. Not all compartments were equal. Some membranes leaked too easily. Some were too rigid. Some trapped useful molecules. Others didn't. But a few, by chance, worked better. They grew. They divided. They maintained internal chemistry. Over time, selection favored systems that could regulate what crossed the boundary, taking in nutrients, releasing waste, maintaining internal balance. These were no longer just protocells. They were the earliest true cells. The first cellular life. These first cells were simple, by modern standards. No nucleus, no organelles, no complex machinery. But they had three defining traits. They were enclosed by a membrane. They maintained internal chemistry, and they could reproduce. That was enough. Once life became cellular, evolution accelerated. Cells could specialize. Metabolism could grow more complex. Information could be stored more reliably. The cell was not just a container. It was a platform for everything that followed. A new era begins. Every living organism on Earth, plants, animals, fungi, bacteria, shares the same basic architecture, a boundary, an interior, a system maintained against entropy. The first cells marked a turning point in the history of life. From this moment on, evolution had a stable foundation. And with that foundation in place, life was ready for its next great transformation. Because the next challenge was not survival, it was information.